Have you ever watched a sci-fi movie and wondered, could we actually do that? Could we zip across the galaxy in a starship, or maybe even journey through time? It sounds like pure fiction, but the line between what's possible and what's impossible in physics is blurrier than you might think. Today, we are rediving deep into the science behind some of the most mind-bending concepts out there: warp drives, time travel, and the enigmatic power of black holes. Let's start with the holy grail of space travel, the warp drive. We've all seen it in shows like Star Trek. A ship engages its drive and streaks across the cosmos faster than light. In our reality, Einstein's theory of special relativity is pretty clear. Nothing with mass can travel at or faster than the speed of light. It would take an infinite amount of energy. So, case closed. Right? Well, not exactly. In 1994, a physicist named Miguel Alcubierre proposed a mind-bending idea. What if, instead of trying to move through space, you could move space itself? Imagine you're on a surfboard. You're not moving faster than the water. The wave is carrying you along. The Alcubierre drive works on a similar principle. It would theoretically create a bubble of spacetime around a spacecraft. This bubble would compress spacetime in front of the ship and expand it behind. The ship itself would stay perfectly still inside this bubble, not violating any laws of physics. But the bubble would move, carrying the ship with it, potentially at speeds far exceeding that of light. It's a brilliant concept, but there's a huge catch. To create this spacetime bubble, you'd need something called exotic matter with negative mass, or more precisely, negative energy density. We've never observed matter like this. All the matter we know from you and me to the stars and planets has positive mass and positive energy. Negative energy is something that, for now, only exists in our equations. Some theories, like those involving quantum mechanics and wormholes, suggest it might be possible, but we're a long way from bottling it up to power a starship. So while the Alcubierre drive is a fascinating theoretical possibility, it remains firmly in the realm of the highly improbable until we can solve that little negative energy problem. Okay, so maybe zipping across galaxies is off the table for now. What about traveling through time? This is another staple of science fiction, but it's also deeply rooted in real physics, specifically in Einstein's theories of relativity. Let's talk about time dilation. Special relativity tells us that the faster you move through space, the slower you move through time relative to a stationary observer. This isn't a theory, it's a proven fact. GPS satellites have to constantly adjust their clocks because they are moving so fast and are in a weaker gravitational field than we are on the surface. If they didn't, our GPS navigation would be off by several miles every single day. The effect is tiny at these speeds, but it's real. If you could build a spaceship that travels at, say, 99.9% the speed of light, you could travel to a nearby star and back in a few years of your own time, only to find that decades or even centuries have passed on Earth. Congratulations, you've just traveled into the future. But what about the past? That's where things get much trickier. For that, we need to look at Einstein's other masterpiece, the theory of general relativity. General relativity describes gravity not as a force, but as a curvature of spacetime caused by mass and energy. Imagine a bowling ball on a trampoline. It creates a dip. That's what massive objects like stars and planets do to the fabric of spacetime. The more massive the object, the deeper the dip and the stronger the gravity. Now, let's bring in the most extreme objects in the universe: black holes. A black hole is a region of spacetime where gravity is so strong that nothing, not even light, can escape. It's the ultimate cosmic pit. The curvature of spacetime near a black hole is immense. And here's where it gets wild. This extreme curvature doesn't just affect space, it dramatically affects time. This is called gravitational time dilation. The stronger the gravity, the slower time passes. Let's imagine a brave astronaut, let's call her Amelia, orbiting a supermassive black hole, like the one at the center of our galaxy, Sagittarius A*. For every hour that passes for Amelia in her ship, orbiting just outside the point of no return, years or even decades could pass for us back on Earth. From her perspective, she's watching the future of the universe unfold and fast forward. This is the science behind the movie Interstellar. She is, in a very real sense, a time traveler. But this is still only travel to the future. To go backward, you'd need to do something even more exotic. You'd need to create what's called a closed time-like curve. This is a path through spacetime that loops back on itself. Theoretically, if you could follow this path, you would end up at a point in your own past. One way to create such a curve might be with a rotating black hole, or more famously, a wormhole. A wormhole, or an Einstein-Rosen bridge, is a theoretical shortcut through spacetime, connecting to distant points. If you could manipulate a wormhole, perhaps by moving one end of it at near light speed and then bringing it back, you could create a time difference between its two mouths. Stepping through one way would take you to the future, and stepping through the other would take you to the past. But just like the warp drive, this comes with its own set of paradoxes and problems. What if you go back in time and prevent your own parents from meeting? This is the famous grandfather paradox. It creates a logical contradiction that many physicists believe makes travel to the past impossible. Some theories suggest that the universe has self-correction mechanisms, or that any attempt to change the past would simply create a new, parallel timeline. We just don't know. And of course, creating and stabilizing a wormhole would likely require that same old troublemaker, exotic matter with negative energy. So, are these ideas truly impossible? The truth is, we're at the very edge of our understanding. The physics of warp drives, black holes, and time travel push our current theories to their absolute limits and beyond. They force us to confront the deepest questions about the nature of reality, space, and time itself. Concepts like negative energy might seem like a roadblock, but in science, roadblocks are just challenges waiting for a breakthrough. Maybe one day, a future physicist will have a new insight, a new theory that turns science fiction into science fact. For now, these impossible ideas serve as a powerful source of inspiration. They fuel our imagination, drive scientific inquiry, and remind us that the universe is far more strange and wonderful than we can possibly imagine. The next time you look up at the night sky, remember that woven into that fabric of space-time are the possibilities of journeys we can currently only dream of. Thanks for joining me on this cosmic journey to the edge of possibility. If you enjoyed this exploration of theoretical physics, make sure to hit that like button and subscribe for more deep dives into the mysteries of our universe. Let me know in the comments which impossible idea you'd love to see become a reality. Until next time, stay curious.